For today's lesson, we'll talk about the inverse of a matrix. So first, let's consider a square matrix A of size n. We say that A is a non-singular matrix if the RREF of A is the identity matrix I sub n. Otherwise, A is called a singular matrix. Another equivalent definition is A is a non-singular matrix if AB is equal to BA, and which is also equal to I sub n for some square matrix B. If such matrix B exists, we call this the inverse of the matrix A, and is now written as A inverse, this one, instead of B. Likewise, if there is no such inverse matrix, then A is a singular matrix. The main goal of this lesson is to identify a square matrix A if it is non-singular or singular. In addition, if A is non-singular, find the inverse matrix of A. So what are the steps to find the inverse matrix of A? First is we write this matrix. It is like an augmented matrix where the left part is A, but the right part is I sub n, or the identity matrix. Second step is apply elementary row operations, or EROs, to transform A to its RREF. If the obtained RREF of A is the identity matrix I sub n, then the right part is A inverse. That is, the matrix of this form from step 1 is now of the form I sub n first in the left part, and the A inverse is on the right part. If the REF of A is not the identity matrix, then A is singular. In fact, while solving for the REF of A, once there is a row consisting entirely of zeros, even if we are not yet obtaining the REF, then we can already conclude that A is singular. Let us have this example. Find the inverse of A given this matrix if it exists. First is we write the matrix that looks like an augmented matrix. The left part is the matrix A, and the right part is identity matrix I sub 3, since A is size 3 by 3. Next, we perform elementary row operations to achieve the REF of A on the left side. We already have the leading one on the first row. Below that are 0 and 5. We want 5 to be 0, so we subtract 5 times row 1 from row 3. The rows 1 and 2 will remain. So let us solve here. 5 minus 5. So multiply all this row 1 by 5. So we have 5 minus 5, we have 0. 5 minus 5, 0. 1 minus 5, negative 4. 0 minus 5, negative 5. 0 minus 0, 0. 1 minus 0, we have 1. Note that whatever we do to a row of A, we also do to the corresponding row of I sub 3, like what we did here. Now let's move to the second row. In the second row, the leftmost non-zero entry is 2. So we divide the second row by 2. The rows 1 and 3 will remain. Let us solve. Here we have 0 divided by 2, that is still 0. 2 divided by 2, we have 1. This will be 3 halves. Again, whatever we do to our row in the left part, we also do to the corresponding row on the right part. So 0 over 2, we have 0. 1 over 2, 1 half. 0 over 2, 0. Remember that in RREF, the column that contains the leading one must be 0 on the other entries. So entry 1 here on the first row, this one, must be 0. So what we do is subtract the second row from the first row. We have row 1 minus row 2. So row 1 minus row 2, 1 minus 0, we have 1. 1 minus 1, 0. 1 minus 3 halves, you have negative 1 half. 1 minus 0, 1. 0 minus 1 half, negative 1 half. And then 0 minus 0, we have 0. Next, let us divide the third row by negative 4 for us to get the leading one on our third row. We have negative 1/4 times row 3. Both zeros here will just be zeros again. For the third entry, negative 4 divided by negative 4, we have positive 1. Negative 5 divided by negative 4, that is positive 5/4. 0 will still be 0, and then this one will be negative 1/4. Next, let's make negative 1 half and 3 halves be 0 above the leading one of third row. So first, let us add 1 half times third row to the first row. So row 1 plus 1 half of our third row, that is 1 plus 0, still 1. 0 plus 0, 0. Negative 1 half plus 1 half, that would be 0. If we multiply this by 1 half, we have 5/8. Then add this to 1, we get 13/8. This is still 0 when we multiply by 1 half, so we have negative 1 half. Then negative 1/4 times 1 half, that is negative 1/8 plus 0, negative 1/8. For the second row, we want this 3 halves to be 0. So what we do is row 2 minus 3 halves of row 3. Multiply the row 3 by 3 halves. Both zeros here will still be 0. So just copy the 0 and 1 here. 0 and 1. Next is 3 halves minus 3 halves. We have 0. 0 minus, what will this be? 5/4 times 3/2 will be 15/8. So 0 minus 15/8 will be negative 15/8. 0 times 3 halves, that is still 0. So we have 1 half here. And then negative 1/4 times 3 halves, we have negative 3/8. So 0 minus negative 3/8, that is positive 3/8. The REF of A is I sub 3. Therefore, A is non-singular, and the inverse of A is the one on the right part, starting from 13/8 and ends at negative 1/4. This one. For our next example, find the inverse of A, this matrix, if it exists. We start with writing the matrix A on the left side and the identity matrix on the right side. We already have our leading one on the row 1. Then let us make the entries below this leading one 0 by first subtracting the first row from the second row. So we have row 2 minus row 1. Row 2 minus row 1, 1 minus 1, that is 0. Negative 2 minus 2, you have negative 4. 1 minus negative 3, you have positive 4. 0 minus 1, negative 1. 1 minus 0, 1, and 0 minus 0, 0. Then to make this entry 5 be 0, what we do is row 3 minus 5 times row 1. So multiply 5 on row 1, then subtract it from row 3. So 5 minus 5, 0. Negative 2 minus 10, negative 12. Negative 3 minus positive 15. we have 12. 0 minus 5, negative 5. 0 minus 0, 0. And then we have 1 minus 0, that is 1. Next, the leftmost non-zero entry on row 2 is negative 4. So let's divide the second row by negative 4. We have negative 1 4 times row 2. This will be 0, 1, negative 1. Negative 1 divided by negative 4, we have positive 1/4. 1 will be negative 1/4. 0 will still be 0. To make the entry below this leading one a 0, we add 12 times second row to the third row, or row 3 plus 12 times row 2. Rows 1 and 2 will remain. Row 3, 0 plus 0 will still be 0. Negative 12 plus 12, that is 0. 12 minus 12, that is 0. Then just do the same. On the right part, you have negative 2, negative 3, and 1. We can already stop at this point since we obtained a row consisting entirely of zeros, this row. Our REF cannot be then the identity matrix. Therefore, A is singular. As an exercise, find the inverse of the following matrices if it exists.